Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode we're gonna take a closer look at SAS or basically serial attached SCSI drives, basically the server hard drives. So let's dive right into it. Now first thing you have to understand, all we are talking about is what we classify as data interface, basically going data from one place to another. So you have to understand, in the early days the hard drive sizes used to be in MB. 200 MB hard drive supposed to be like the cool kit. So you have to understand, we have capacity that has multiplied exponentially. So at this point in time you can literally go to a market and buy a hard drive that has upwards of 12 terabyte, and if you have access and pull at some places, you can get enterprise hard drives that are like even bigger than that. So at this point in time our capacity has grown exponentially. And let's also discuss about the speed. It's no point having a very big capacity hard drive if you can't transfer fast enough. So you're not gonna use like a micro SD which has 2 terabyte to watch movie from that, because it will take forever. So our speed has also multiplied. So we went from SATA 1, which was barely 150 Mbps, then SATA 2, which was barely 300 Mbps, then SATA 3 that we are using right now, that goes upwards of 600 Mbps. So you can see our speed is also getting doubled every time. Now our interface market has also adapted to it. Basically, if you are old enough, you will remember these sort of PATA cable that was used for connecting hard drives. There are a lot of interesting hassles, like you to connect two, that's why there is always two. You have to have one master, one slave. Yeah, it was a whole complicated mess. So this also changed because this was not efficient enough, and it was basically parallel. So in principle parallel sounds good, but because of the chips that were behind it, they were not that good. So the speed that you will get on these were not good enough. But then again, that changed. We've changed from PATA to SATA. This is your current interface. SATA can go upwards of 600 Mbps as of current latest revision. So this is the consumer side. What about the problems that we face because of this consumer oriented nature? Now first thing is the speed is limited. You really can't go very fast. You can't even touch 1 gigabyte per second. So that's a very big issue if you are trying to serve a server. Then the cable run. Now cable run is not an issue for your basically cabinet, which is a normal computer cabinet would barely need a cable that is like 1 foot, or sometimes let's say 2 foot if you are doing cable routing. But in case of a server, you can easily run in a scenario where you have processor at the top of the server and a lot of other things like a hard drive base into going down. So at the lower end you could have a scenario where you need upwards of few meters of cable to make sure you go that far. So cable run also becomes a crucial aspect. Without having the ability to make very long cables, you can't daisy chain a lot of hard drives. It becomes an issue. And SATA is built for public use. So it's basically built with one extra time. You want to write something, okay, tell me, I'm gonna write it. Now you want to read something, hold up until the write operation is done. It will wait, and once that is done, it will give you the right one. Now because it's 600 Mbps, it's fast enough that we don't notice it. But for a consumer environment, that's more than good enough. But when you're talking about, let's say, server where you have hundreds of banking client directly trying to read and write information, basically transaction information, you cannot wait that long. So that is an issue. And in terms of how much stress it can handle, this is the final breaking point. The stress management for these sort of hard drives, they are not very good. They cannot have like hundreds of information that is queued up and it will take care of one after one another, which is necessary for anything that is mission critical. So if you have a server that is taking care of security, or you are having a server that is taking care of something very crucial, mission sensitive, like air traffic controller, you cannot have a scenario where hard drive just, oops, I forgot that one one read write information that is supposed to do. It has to do everything every time reliably. So this is the limitation of our normal interface that you have with PATA and SATA. Then we move up to serial attached SCSI. Now you have to understand this. SCSI is same as PATA. It used to also come for parallel SCSI. Now it's moved to serial, same as PATA and SATA. Now the core difference between this and your normal system is basically the backbone, the code, the protocols, the everything that is built on. It's very stable. It was from day one built for enterprise use. So it's not there is no corner cutting into this. So every aspect of it, every driver, every line of code that has been written for this is written in such a way that it will never slow down. It will, and if something happens, let's say crash happen, it can reliably tell you what happened. This is very crucial. You cannot have a scenario where, okay, let's say you transactioned, let's say a money transaction transaction happened, the computer has to store data, because there is no real money going from point A to point B when you are swiping your ATM card or doing a deposit using credit card. It's just information. That information, let's say for some reason hard drive failed, the SCSI interface will notify it like, dude, it failed, go to a backup system, go to a backup system. So this sort of thing happens in SCSI. Now this, when you hear this SCSI, what does that mean? Small computer system interface. Now if that name sounds silly to you because it's in 1980s when they come up with this idea, so back in their day that was the name. So but now we are running with it. Basically we call SAS hard drives, and SAS has same way SATA has SATA 1, SATA 2, SATA 3. SCSI also has many iterations. So latest iteration, basically SAS 4 iteration can go up to 22.5 Gbps, or basically 2.8 gigabyte per second. Now this is why people need it. This is what you, if you go to a server room, like let's say of any big corporation, this is what you will find. You won't find SATA hard drives. You may find that in, let's say, Netflix, because Netflix is basically doing streaming, but you won't find that for YouTube, because YouTube have a lot of interaction, a lot of comments going back and forward. So in those sort of scenarios, these things are needed. And you can see the backplane is also built in such a way that you can just plug in the hard drive, remove it if it goes faulty. Everything about this is built in such a way that it can remain 24/7 up all the time, no matter what happens. So they inherently have multiple fail-safes. They inherently have multiple redundancy pathways. So basically, let's say you have backplane, you put 4 hard drives into it. Let's say now this backplane is connecting to your processor. If it will be connected in such a way that if one link fails, it will go to another link. It will not just randomly, crap out. So understand, this is built from day one for enterprise grade. Every aspect of this is built for such a way. So that is what SAS is. Everybody talk about SAS. This is what they are talking about. Basically, a upgraded version, enterprise grade edition, and it has some certain advantages like reading and write at the same time. Now that information and the magnetic platter, it is more or less the same as your normal hard drive. However, because it's a reading and write at the same time, it could have like one platter that is like reading the information, another platter that is writing the information. So this is the whole old architecture that we used to. SAS is now becoming obsolete. So what we can expect in the future, if SAS is like, the whole enterprise grade thing is becoming obsolete, what can we expect in the future? Now you have to know, NVMe is starting to replace it all. Now NVMe, the core aspect of NVMe is that it's directly based on PCIe Express lanes. Now PCIe used to be an old interface, then PCI Express came along, which is very fast, and the aspect of that is very crucial for everyone is that it's directly talking to your processor. Basically is the second fastest link to processor after RAM. So if you want to get the highest bandwidth possible, RAM is the place to go. But after that, after RAM, the second fastest place would be PCI. So people are like, okay, let's use that itself for our data transmission. Now it's coming for both. NVMe, the architecture is built in such a way that it can handle both. It can handle consumer and enterprise. Basically it can be cheap enough for consumer and it can be expensive enough for enterprise, and the protocol would be the same. NVMe protocol would be the same. Of course you will have, like, let's say in case of enterprise or in such a scenario, you will have extra layers of security, extra encoding, decoding and encryption chips, but other than that the base protocol will remain the same. However, the connector, this is the crucial aspect, the connector would be different. So for consumer use, whenever you type NVMe on a normal basically eBay or Amazon, you get what we call M.2, this sort of thing, what you are familiar to. Now this is built for consumer. It's cheap, it's efficient, it's built for just plug and play kind of information. Now it is very good, it does what it's supposed to do, but it does come with a consequence. This sort of architecture is not suitable for server, because these puppies get hot, and they get very, very hot. So you can understand, nowadays there is a company that is giving you heat pipes to plug into your this drive and cool it down. Now in a server scenario, this will be running at that temperature 24/7. That simply will not work. And the way it's meant to be mounted, you cannot hot swap these. Like, even though let's say they wrote a software that allows it to be hot swap, it simply would not allow you hot swap, because you have to remove a screw here. So there is a second standard. This is the first standard. This is what you will find in your laptop and your desktop, but there is a server grade basically alternative to this, which is called U2. U2 look like more or less normal hard drive, and that is the idea. So let's say you have a server rack, you have to make sure that if one drive goes faulty, you can quickly remove it out, plug a new one in, and it must have in such a way that it can be cooled. Basically the air cooling must be feasible. This cannot be air cooled properly. You can say, like, you have to buy very, very fancy things But for this, it's literally relies on the same fan, relies on the same airflow architecture that old hard drive used to be. That is why U2 is built for server integration and M2 is built for UNI. So this is the future. SAS hard drive, will they survive? Of course, they will keep trying to refresh it, and at some point, because this do come with one consequence, this requires very serious high-end processor, because you are doing the PCIe Express processing, you must have a processor that can handle that. So it is very, like, because of its high speed, it does need high speed processor. So it will take some time to replace SAS, but soon it will be done because of the core aspect. Because NVMe is built from ground up, it can go very fast. As of now, you can buy a SAS, basically NVMe system that can give you upwards of 2.5 gigabyte read and write at home. This is the aspect. And in enterprise grade, you can easily find something that can go up even higher than that. So for this reason, this is the future. Now, will SAS evaporate? No, it will slowly be phased out. Same way we phased out PATA hard drives, we're gonna phase out SAS hard drives. Now, it could change forever. Some SAS, because there is a corporation that is taking care of SAS, its interface, its command lines. They may do something unique and make it live longer. But as of now, as I believe it, is NVMe is gonna replace it sooner or later. So this was my presentation on SAS hard drives. I hope you liked it, learned from it. In that case, please leave a like. If you didn't like it, don't worry about it. You can press dislike. I would urge you to press it twice to show me your extra disappointment. And if you weren't disappointed, please click the ad that are shown in this video. That will directly help me. And leave a comment because I reply to all of them. Subscribe and press the bell icon if you're free. And as always, thanks for watching.